Every other Git tutorial shows you commands. This one shows the data structures Git mutates on disk. Episode 4. Let's begin. Previously, we saw trees. A tree is a flat list of entries. Each entry points to a blob with a file name. This works perfectly for one folder of files. Keep that picture in mind. But real projects have folders. Source code lives in SRC, tests live in tests, documentation sits alongside, multiple levels deep. So how does a flat list of entries handle this? Take a moment to look. How does a flat list store a folder? The answer is on disk. We will see it ourselves in a moment, and it is simpler than you think. Git did not invent a new mechanism. It used the one we already learned. Let's build a repo with a folder, then watch what Git puts on disk. Coming up next. Quick recap. Trees are flat lists. Real projects nest into folders. Next, we build it and watch the disk for ourselves. Segment 2. Building a nested repo. We are in our repo from before. 2 commits, 2 trees, 3 blobs, 5 real folders inside .git/objects. Now we add a folder. Make a directory called src. Put 2 Python files inside, main.py and utils.py. Git does not know about any of this yet. Git add src/ stages everything under the folder. Then commit. Git reports the new commit 5843 and so on. 2 files changed. Now look again. 5 new folders, 1 commit, 1 new top-level tree, 1 subtree, and 2 new blobs, 1 per Python file. 5 objects from a single commit. 5 new objects. One of them is src, but which? Open the commit, follow the tree. Next. Recap. 1 commit created 5 objects, a commit, a top tree, a subtree, and 2 blobs. Trees inside trees. Today we follow the trail from a commit down into a directory and find Git repeating itself. Open the latest commit, catfile-p on head, parent, author, committer, message. The tree we want is 923b. Now open that tree. 4 familiar lines, blobs, file names, we've seen this. But look at line 5. 100644 became 040, and the type says tree. A tree can contain another tree. 040 is the directory mode. The hash points to another tree object, and the name column holds a directory name. Open the subtree. Catfile-p on B7, 2 entries, mode blob, hash file name, the same shape as the top tree. It is just another tree. A commit points to a tree. The tree points to blobs and to another tree. That tree points to its own blobs. The recursion is the mechanism. Trees inside trees. But how deep can it go? 5 levels, 10, 20. The answer stays the same. Next, we find out. Recap. Trees can contain trees. The mode 040 marks a directory, and Git's object graph is recursive by design. Trees inside trees. We saw it work for 1 level, but real projects are deeper. 5 levels, 10, 20. How does Git handle that? Imagine this path, my project, /src/utils/helpers/stringutils.py, 4 directories deep, 1 file at the bottom. Each slash in the path is 1 tree object pointing to another. The root tree points to src, src points to utils, utils points to helpers, helpers finally points to the blob. 4 trees, 1 blob. Nested directories are not a special feature in Git. They are an emergent property of trees being allowed to point to other trees. That is all. Now think about 2 commits, the full picture. Coming up, recap. A deep path is just trees pointing to trees, no special mechanism, just recursion all the way down. Previously we built trees and blobs. Now let's put it all together. 1 commit, 1 nested project, the complete object graph. 1 commit at the top. It points to the top level tree. The top tree points to 4 blobs directly, and to a subtree. The subtree points to its own 2 blobs. Trees in the middle, blobs at the leaves, always. Now imagine 2 commits, a few seconds apart. Most files in the project did not change. Maybe you edited 1 or added 2. The rest are identical. So what does Git do? Most developers guess one of 3 things. Maybe it stores diffs, maybe it resaves the changed files, maybe it does something clever with deltas. Git does none of these. Its answer is simpler and weirder. Once you see it, you cannot unsee it. Episode 5. Snapshots, not diffs. Commit points to tree. Tree points to blobs and subtrees. That is the full object graph. If this is the Git tutorial you wish you'd had, subscribe. One episode at a time, all the way to the metal.